Welcome to the non-precipitating types module for ForecastBuilder. It's a little bit of a longer module just because some of the tools have a little bit more information for us to unpack. But we want you to have a good understanding of how everything is working. So here's the GUI, a lot of tools to populate the non-precipitating types, including dust, fog, frost, haze, pot severe, pot thunder, smoke, sprinkles, flurries, freezing spray, and blowing snow. You'll see that in this example, freezing spray and blowing snow aren't in the GUI, and that's because when the temperature is greater than 40 for the entire time range that's selected, then those options will not appear. There's a delete all option, which gives you a clean slate, will wipe out all the non-precipitating type grids. But you don't need to run that every time. Say you just have pot frost and you want to update that, you don't need to delete it. You can just click pot frost to update it using the tool. We're going to start with pot severe. Pot severe is composed of two components. We marry the SPC categorical outlooks to the 3-hourly SREF calibrated severe probabilities. So the day 1 is at the top, day 2, 3 at the bottom of the GUI. We set the minimum risk category, which by default is slight. So that means anywhere we have a slight, enhanced, moderate, or high risk, we can potentially get a T+ mention. If you want that to begin at marginal, well, then you need to move that radio button. And that's married to the 3-hourly SREF calibrated severe probability thresholds, which can be adjusted via the slider bar. And the result is that pot severe is a binary yes-no grid. T+ is added at the merge weather step anytime pot severe is greater than or equal to 30. So when these two conditions are tripped, the SREF probability within the categorical mask from SPC, that'll give you a value of 30 for pot severe. So the T+ mention will move spatially and temporally within the SPC outlook area as the threat changes in time through via the SREF probabilities. You'll notice that there's edit area and time range to use options at the bottom of the GUI, as you'll see in nearly all the GUIs for the non-precipitating types. And that's to allow you to choose if you want to make any adjustments to the edit area or time ranges that ForecastBuilder is using. There's pot severe on the left and the weather grid on the right. There's where the 30 value for pot severe, where the SRF probabilities have been tripped within the SPC categorical mask. And that's where at the merge weather step you can get T+, and those severe attributes such as large hail and damaging wind. Subsevere attributes such as small hail can be added can be added at the merge weather step anytime thunder is mentioned. Pot thunder has two methods, and we're only going to run them from the non-precipitating types step if we're not using the NBM as the precip type approach. That's because you can populate pot thunder from that earlier step. So pot thunder from the NBM. This uses the MOS-based calibrated total lightning data that's available from the various sources on the right, which you can see in the table. 1 hour probabilities for the first 36 hours, 3-hourly for hours 36 to 84, and 6-hour probabilities after 84 hours. The probabilities, again, are MOS-based, calibrated to total lightning. No GUI is going to appear when you select this option in ForecastBuilder. These probabilities will simply be populated in as delivered from the NBM. The second method is pot thunder from POP, which uses the legacy copy POP to pot thunder tool. The default slider bar positions will simply match pot thunder to POP. You can adjust these to limit a thunderstorm mention. Say you want more of a rain shower mention and lesser thunderstorm mention. You can move the maximum value for pot thunder to below your highest POP. Pot fog from dew point depression. Fairly simple, more legacy tool that sets your maximum dew point depression and wind speed thresholds for patchy areas and widespread fog. And you're able to cap your coverage at areas are patchy if you so choose. Pretty standard 20, 40, 70 are the values that you'll get. 20 for patchy, 40 for areas, 70 for widespread will be populated into pot fog, as well. It's kind of the standard values that you'll see for most of these non-precipitating types for that patchy area, widespread mention. Pot fog from visibility will calculate pot fog, again, based on dew point depression, and then the visibility grid. And so because you're using the visibility grid, it integrates pretty well with DAS. First thing you're going to do is set your dew point depression, where you allow pot fog to be calculated. Again, that's based on your temperature dew point grids. And then the visibility is what's going to control the patchy area and widespread mention. Pot blowing dust, this is the simple minimum wind gust tools, which just sets the minimum wind gust for patchy areas and definite blowing dust. There's blowing dust model, which uses the NSIP air quality surface fine particulate matter concentration. This works well for gradient wind-induced blowing dust, but does not handle that dust that's produced by convective outflows. And the ForecastBuilder team is working on that and is aware of that. So you're just going to set your minimum concentrations for patchy areas and definite for blowing dust. Again, based on that fine particulate matter concentration at the surface. Smoke and haze. What you're doing here, very similar to what you're doing for dust, is that you're setting a minimum concentration. This time you're using the near surface smoke concentrations from the HRR, and you can use the slider bars to adjust that if needed. And you want to select the smoke coverage mention, so patchy areas or definite. And that, again, setting the minimum concentration for a haze mention and for a smoke mention based on your near surface smoke concentrations from the HRR. There's also a simple haze tool, which is just based on visibility, below which you allow haze to exist or to be populated in. Because it works with your visibility grid, it works well with DAS. Pot freezing spray, calculated in the background using the Overland 1990 algorithm incorporating water temperature, air temperature, and wind. The values are unitless. They're not in centimeters per hour or inches per hour. It's automatically binned in the background to none, light, moderate, or heavy. And again, we want to focus in on that heavy category for heavy freezing spray watches and warnings. There's no GUI that appears when you select this option. It just automatically runs in the background. Pot frost, another tool that just runs in the background when you click on it. It's a tool that is based on temperature, wind, dew point depression, and cloud cover. And that comes from University of Kentucky research. So all that logic that you see on the right is what's going to be run in the background to calculate the frost. Sprinkles and flurries. A few options that we have here is at what pop do we want to start to get flurries and sprinkles mentioned, and then what value do we want to assign to sprinkles and flurries. And that corresponds to our standard pop categories as shown in the table. There's temperature thresholds for all flurries and all sprinkles as well. The most complicated non-precipitating type is blowing snow. And that is largely due to the characteristics of the snowpack that we're trying to take into account. So we're going to kind of dive into this. The current methodology for blowing snow within ForecastBuilder marries up two methods. The first is based on a study from NWS La Crosse, which used two ASOS sites in southeast Minnesota, southwest Wisconsin, to really highlight those lower end impacts, especially for drifting snow. But this study didn't incorporate the influence of the snowpack characteristics. So generally around 17 knots is when we see that blowing snow, or excuse me, the drifting snow really start. And that's what we're really trying to use this study for, is taking into account that drifting snow. Again, that's pretty common. Those probabilities for that really increase around 17 knots and above. The other component is that we use the Bagley blowing snow model, which comes to us from the Canadians. This is a statistical model which incorporates snow rate, temperature, wind speed, and snow age. So it takes into account more factors that influence blowing snow. Again, we marry that to the La Crosse study, which handles kind of the lower end drifting snow fairly strongly. So what is snow age? Well, this is an internal calculation that determines how old the snow is, and it's looking back 24 hours. The maximum snow age is 25 hours, and that's because beyond that, the calculations really, there's not much change in the output beyond that, the way the calculations are set up. So it's looking back in the GFEOBS database and trying to see when it snowed, and it resets the snow age to 0 anytime you get new snow. And then as you march out into the future, in your forecast, then it's using your pop and snow mount grids to be able to reset that snow age to 0 where we get new snow. Another key component of this is that the snow depth grid, which uses the Norse data looking back 180 hours, and it assumes that it wants to know when and where did this snowpack crust over, and so that's anytime the surface temperature is greater than 35. Once that has been reached, the snow depth is set to 0. It also will be 0 where there's no snowpack, obviously. So this is really kind of a good mask for where the snow can be lofted, and then where it can't be, because then you're setting the snow depth to 0 where it has crusted over. We'll go through it, but what you're going to do is you'll get flagged with this GUI that'll pop up saying to look at this single snow depth grid, and you can add snow in if there's part of the snowpack that may be missing. Just at least set it equal to greater than 1. 1 will give you a kind of limit you to areas of blowing snow, but if you set it to greater than 2 inches, you have no limits to what blowing snow can come out as, and we'll talk about that. Or you can set it to 0 where you think it's crusted over or where it has too much snowpack. You don't want to make any more than one snow depth grid. It's done in the future for you based on temperatures and new snowfall. So snow depth is taken care of into the future. So again, this marries up the best of both methodologies using wind, temperature, snow rate, and snow age. And this is kind of what this all comes out to be. Patchy. Blowing snow is going to come out at wind speeds greater than or equal to 17 knots, or at least a 10% chance of falling below 3 mile visibility from the Bagley method. Areas is 30% or greater probability of falling below 1 statute mile from the Bagley blowing snow probabilities. Definite is a 60% or greater chance of falling below a half mile, and then blizzard is an 80% or greater probability of falling below a half mile, and you'll get that quarter mile tag at the weather grid as well. So again, marrying up the best of all the methodologies to give us our best interpretation of blowing snow, with the focus of trying to take into account the best we can the snowpack itself. So kind of breaking that down even more, patchy is kind of an all-encompassing term, and either low impact blowing snow or more just so drifting snow, and especially the problematic drifting snow where the road temps maybe sub-freezing to begin with, but then we heat up during the day and the snow starts to blow across it and stick to it, and we just cause somewhat of a mess. Areas of blowing snow is kind of those low to medium impacts, probably thinking about advisory-esque kind of things. Definite blowing snow, those really high impact blowing snow events, maybe even approaching blizzard criteria in some locations or near blizzard conditions, probably a solid warning kind of level criteria. And definite with the quarter mile tag is blizzard conditions. So let's bring this all together again. The Bagley blowing snow model, again, it is trying to take into account the best it can the condition of the snowpack. So you're going to get that flag for looking at that snow depth grid. Where snow depth is less than an inch means no snow can be lofted, or there's simply no snow. It could mean that too. But by saying, okay, the temperatures here have been too warm, it's crusted over, the snow's not going to move. Any snow depth between 1 and 2 inches essentially is going to be limited, so that you can only get a pot blowing snow to 24, which essentially is a patchy mention. Snow depth greater than 2 inches, there's no restriction. Pot blowing snow can come out to be whatever it falls out to be from the modeling. So again, looking past 8 days, see where a crust happened, setting the snow depth to 0, and that's done on the fly, and you can again adjust this snow depth grid if you need to add snowpack or take snowpack away. And then in the future, you're marching out using your forecast temperatures and snow to be able to adjust that snow depth grid, and also marrying that with the snow age grid. The tool is also going to try to determine if there's falling or no falling snow. Obviously, you can get to a lot lower visibilities easier with falling snow compared to no falling snow, so there's different equations that are used, and you interpolate between no falling and falling snow between a 50 and 60 pop. And what's coming out of this, again, are probabilities from the Bagley model of falling below certain visibility thresholds. And that's tied to pot blowing snow values. And this is what we see here is the Grand Forks CWA, the blizzard capital, and they've done a lot of research into really associating impacts with the output and the probabilities. So a 1% pot blowing snow, that's really your drifting snow. That's where we see that condition of that 17 knots. So again, really looking at where just that drifting snow is, which can be impactful, especially if it's sticking to the road when our temperatures warm up and the road temperatures warm up through the day. There's a configuration available within ForecastBuilder to set an edit area for sheltered areas, say heavily treed areas where pot blowing snow is capped at 49% or areas unless the snowfall rates are high enough. Again, the Bagley models take into account snowfall rate, which is essentially kind of parsing out your 6 hourly snow amounts into 1 hourly, the snow age, forecast temperatures, and forecast wind speed. So pot blowing snow of 1% to 24% is a minimum impact. Apache mentioned, and wind speeds greater than equal to 17 knots, or at least a 10% probability of the visibility falling below 3 miles. 25 to 49% is you will get areas, maybe kind of low-end advisory. 50 to 79% moderate impact. This is going to be definite. This is kind of a solid advisory. You're maybe thinking about warning, kind of maybe even some sporadic areas of approaching blizzard conditions. Then pot blowing snow of 80 to 100% is going to be a warning level. Essentially, this is essentially meeting your blizzard criteria, at least from a visibility standpoint. You're going to get that quarter-mile tag within the weather grid, and an 80% or more probability of falling below a half mile. And obviously, we have a half mile here, but blizzard is a quarter mile. But the Grand Forks office has done a lot of work in converting, what this means, this output from the Bagley model means in regards to impacts. So if you have any questions, feel free to reach out to the ForecastBuilder team at nws.forecastbuilder and NOAA.gov. Thanks.